Okay, so what I want to talk about just is I want to do some general inverse trig function discussion and then talk a little bit about 2.8 problems. Okay, so to do an inverse function, we have to restrict the domain. And y is, let's just do that. This is sine, right? The inverse function, for it to be a function, has to pass the vertical line test, right? This does not pass the horizontal line test, which means when I take the inverse of it, it will not pass the vertical line test. So the whole restriction of the domain, the reason we do it, is we're just going to pick, and we could pick any chunk of the sine graph. We're just going to pick a chunk of it that would pass the horizontal line test, so that when I take the inverse of it, it'll pass also. Okay? And like I said, you could pick any chunk that you want. I could do it from here to here. I could do it from here to here. But all the mathematicians of the world, I don't know when, they all got together. Everybody said we need to standardize how we were going to restrict the domain for sine. And so they said, okay, we're going to pick from the peak here to the bottom here. And that's going to be the only piece of the trig, the sine function, that we will take the inverse of. It will only exist between negative pi over 2 to pi over 2. That way, when we take the inverse of it, it is still a function. Okay? So generally, sine is restricted from negative pi over 2 to pi over 2 before you take the inverse. Okay? Cosine then, because it starts here, yeah, comes down, they restrict it from 0 to pi. That's the leg of the cosine graph that's restricted. Okay? Tangent, the very middle part of the tangent graph is there. Okay? So that's the only piece of the tangent graph they use. Because if I used the whole tangent graph, I could definitely pass a horizontal line through every tangent graph and hit more than once, which means when I flip it, it won't pass the vertical line test when I take the inverse. So this is the only part of the tangent graph that's used to find the inverse. Okay, so the difference between the restriction here and the restriction on tangent is this point is included. Okay, negative pi over 2. That's the restriction of sine. What happens at pi over 2 and negative pi over 2 on the tangent? What's there? Asymptote. So I can't include those. So it has the same domain restriction as sine, except it has to be in parentheses instead of brackets, because it doesn't exist at those two values, where sine does. Okay? Secant will have the same restriction as cosine,
okay.
Because secant's 1 over cosine.
Yeah, that makes sense.
Sine will have the same restriction as
Or
cosecant. Yep. And then cotangent actually is going to be the same as cosine, but not include 0 and pi. Because cotangent's graph is actually, this is an asymptote, right? And pi is an asymptote of tangent. Okay, so that's the whole reason, that's the whole background on why we restrict the domain. Okay? Now, when we get into actually looking at functions, let's do that's a pi. Nope, I don't want that. That can't be a pi. Remember, what does this represent? An angle or a value? Let me back up, since I can see confusion. What does this represent? An angle or a value? An angle. So when I take the inverse of it, I replace x and y and solve for y, and I get this. Where's my angle, x or y? Y.
Yeah.
This is a value. The way I read this in English, instead of math, instead of calling it arc cosine of x or inverse cosine of x, what I say is, what angle is cosine equal to this value? Follow me? What angle is cosine equal to this value? So when I'm looking at evaluating this, forget the sign for a minute. I'm asking myself, what angle does cosine equal to the square root of 2 over 2? Well, if I don't know it off the top of my head, which you should, what's this? What's this angle? 45. So this was replaced by 45 degrees. This whole thing. Now I can say sine of 45 is what? Square root of 2 over 2. Okay. The key with these is draw your triangle, because they aren't always going to be 30, 60, 90, 45, 45, 90. Draw your triangle. Once I know the triangle, this is theta, this is theta. I don't even need to know what theta is. If my triangle is correct, to find sine, all I have to do is take the values I put in my triangle and find sine of that angle. Okay? Now, there are a couple of properties that are helpful. The sine of an inverse sine of x is always equal to whatever this is. Okay? However, and this works for cosine and tangent and cotangent and all of them, if this is reversed, though, something to consider here. This is not always x. What does x represent here? A value or an angle?
An angle.
An angle. For me to take the inverse of an angle, or the sine of an angle, is that what I want to do? Yeah. No, I want to do this one. Let's do that. This is not equal to 5 pi over 3. Okay, you think it should be. The problem is, where is 5 pi over 3 at?
4. It's 10 pi over 6.
Well, 3 pi over 3 is here,
Yes.
and then it's another 2 pi over 3 after that, right?
Yes.
So what's that angle? 2/3 pi.
So it would be 40?
Altogether, but this reference angle,
60.
60. Right? The whole angle together is 240, but I'd subtract 180 from it to get my reference angle of 60.
Yeah.
Okay, the question is, can I take the inverse sine of an angle in the third quadrant? Where's the domain restricted? Which is negative 90 to 90. So what quadrants does that encompass?
31? No.
What's 90 degrees? First and fourth,
4.
right?
Oh, yeah, you're right.
Okay. What angle is this one in? Third. Okay, so what I have to do is figure out where sine is equal to the exact same value in either this quadrant or this quadrant. So what is sine of this angle? What's opposite the 60? Right? And I'll talk at once. What's negative here?
The square root of 2, yeah, the 2, you're right.
Okay, so sine of this angle, actually not the 2.
Oh, no, yeah, do the square root. I was going to say, but then I thought, no, okay. I was so confused for a second.
2 is not negative. Square root of 3. So sine is what? The square root of 3 over 2. Negative. But it can only be in one of these two quadrants.
Wait, would the 1 be negative or no? It goes left.
Well, yeah, but I'm not dealing with
Okay.
sine. Sorry. In sine, I don't use the 1.
Yeah, you're right.
Okay, what quadrant is sine equal to sine of 60, the reference angle, equal to negative square root of 3 over 2? First or fourth? If I drew a 60-degree triangle here, what's sine?
Would be 2 inverse.
2 square root of 2.
Okay, if this is 60, let's label the triangle again. What's opposite the 60? What's sine?
Square root of 3 over 2.
That's not negative, right? This quadrant, what's this angle? What's sine?
Negative square root of
Just go down.
yeah, negative square root of
Okay, so the reference angle here and the reference angle here will give me the same value for sine. Okay, so I want the same value for sine to come out of this to be 5 pi, this shouldn't be an angle, should it? So this angle is either in this quadrant or in this quadrant, right? But it must be in this quadrant because sine has to be restricted. So the answer to this one is still the square root of 3. I did it. Okay, I should have done the first one I did. Okay. Sine of 5 pi over 3 is negative square root of 3 over 2. Right?
yes.
The inverse sine of negative square root of 3 over 2 happens in two different quadrants. The third quadrant or the fourth quadrant. I must choose the fourth quadrant because that's where the domain's restricted. So this is going to, the answer, instead of being 5 pi over 3, it's actually going to be what? All the way around is 12 pi over 6 minus a pi over 3, or minus 2 pi over 3, so it'd be 10 pi over 6. No. I want it out of 3, right? This is pi over 3, this is 6 pi over 3. If I subtract 2 pi over 3 from that, I get 4 pi over 3. So instead of 5 pi over 3, the answer to this is 4 pi over 3. Okay? Most of the time, you'll be able to just say, like, with this problem, it's just x. But the times you have to be careful is if you're taking the arc or the inverse of one of those trig functions. If this angle is not in its domain restriction, you have to figure out the equivalent angle that would give you the same value. Let me do another one.
Kind of, yeah.
Tangent of
Oh, yeah, you can do it.
7 pi over 6. Where is 7 pi over 6?
Third quadrant.
What's the reference angle?
30 degrees.
30 pi over 6 either way. Okay, what's tangent here?
opposite over
Let's
here.
label the triangle.
7, 5,
What's this?
7, 5, negative 7.
What's this side of a 30-degree triangle?
Negative 1, yeah, you're right. I'm going insane.
Okay, so what's tangent here? 1 over the square root of 3? Or just the square root of 3 over 3 if I rationalize? That's what I was trying to say. Okay, so the problem is, where is tangent restricted to for the inverse?
Could just be
Which quadrants? No? What's the restriction for tangent? Okay, so what quadrant are these two angles?
I'm thinking.
Okay, this is pi over 2. This is negative pi over 2. My domain is restricted between these two, 1 and 4.
Okay.
This is in 3. This is in 3. Okay, and we just said that tangent here is the square root of 3 over 3. Positive. So which quadrant, 1 or 4, should I try and find the same reference angle for? 1, because tangent's positive in the first. Okay, so the caveat to this property, it will work in all cases, except if the inverse tangent, this angle is outside of that domain. If this were that's true. Basically, this just negates that, and I'm just left with pi over 6. But this is outside the domain restriction, so I have to find the equivalent angle that would give me the same value, and that's the answer. Okay. Most all cases, it will always just be inverse tangent of x is always equal to x. The only time it won't be is if that angle happens to be outside of the domain restriction. Okay, so with all of these problems, the key is draw your triangles, label all sides, and you shouldn't have any problem answering questions. Let's just do one more together.
And you're good for 4 o'clock down there?
Yep.
Okay.
Yep. Is this a value or an angle?
That's a value.
Value. So I'm just going to draw a triangle. It's got to either be in first quadrant or fourth quadrant. And it's positive, so it must be first. If tangent is 3, how could I label the sides of this triangle? What's tangent represent? Opposite over adjacent, and that has to be 3. What's the hypotenuse? Three squared plus 1 is 10. Square root of 10. Pythagorean theorem. Right? What is sine of this same angle? Because that's all I found here. Found this angle, whatever it is. Now I'm trying to find sine of the same angle. Yep. Or either way.
Yeah.
Okay. So just work from the inside, draw your triangle, and then analyze that after. Okay?
Let's hope your